Today we're going to be doing physics, motion under physics. And motion is one very important topic in physics, as a lot of other topics depends on it, right? Motion generally is divided into two parts. We have kinematics and we have dynamics. Motion cannot occur, motion cannot take place without what? Force. For every for motion to take place, force is what is required. So when we are studying motion, without the force that produces the motion, we're talking about what? Kinematics. But when we're talking about motion, and we are discussing the force that produces what? Motion, but then what now? Dynamics. What I'm going to do today is going to be restricted to kinematics. So what is motion? That's the first question you want to ask. What is motion? Motion simply means movement. But in case you are asked to define this in an examination, motion is the change of position of an object. Change of position of an object. The object was here, this is A, and the object gets to this point, B. We say the object has what? Has moved, motion has taken place. And for that to happen, force is required. But I said for kinematics, we are not going to be talking about the force that produces the motion. Alright? Let me just talk a little about different types of motion before I go to terminologies. So if I'm dealing with types of motion, there's so many of them, so many types of motion. I'll just brush over a few of them. One, we have linear or translational motion. Linear or translational motion. Two, we have oscillatory. Oscillatory is sometimes called vibratory motion. We have rotational motion. Rotational motion is not the same as circular motion, though. We have circular motion, and we have random motion. And for 6, we have the other types of motion. We have things like relative motion. I'll just hurry over them very quickly before I go to terminologies. When an object is moving in a straight line, we say what now? A linear motion. For example, I'm moving like this now. What now? That's what? Linear motion in a straight line. If the object is moving to and fro, if I have a pendulum, for example, a pendulum bulb, moving what? To and fro. That is what now? Oscillatory or vibratory. If I have an object that is moving about an axis, like this pen now, it is turning about an axis, or the earth, when the earth goes round, rotates, to go about an axis, I can stay in the same point. This is rotation. Rotate about what now? An axis. That is what now? Rotational motion. Then if we're talking about circular motion has to do with an object going in cycles, going around what now? Circular motion. Like the vehicle that is going, if there's a roundabout, the vehicle turns around it. That's going to be what now? Circular motion. And random motion is half of that motion in all directions, any direction. There's no specified pattern. Like the motion of gas particles, they move in all what now? Directions. Half of that. For relative motion, and let me say this generally in science, when you hear the word relative, it's talking about what now? Comparing. So for relative motion, we're comparing what now? The motion of one body to another one. For example, if two people are running, I want to see how this person's speed is compared to that person's speed. Distance covered is compared. Enter your comparing motion like that. We're doing relative motion. I'm going to talk about relative motion fully on its own when we can spend the time. So let's go to what? Terminologies very quickly. What are some of the terminologies that you're likely to encounter when you are dealing with motions? Terminologies. The first is going to be position. For us to understand position properly, I will need to explain the Cartesian plane. It's going to be difficult for you to locate position of an object on a plane without what now? The use of that Cartesian axis. So it's called Cartesian axis because of the person who formulated it, the inventor of the Cartesian plane is Cartes, right? Now, what does Cartesian plane help me with? If I want to locate this point, I want to describe it to someone outside, or this point, so it's going to be difficult for me to just go out there and say, this is particular point. The point is on it's going to be easier for me to make this, if I can divide this into what now? Into axes. If I can divide this into two axes, and then I label the axis. Usually we have what now? This one axis, we call it the y-axis, and this one what now? The x-axis. So that if I have a point here, I can now find the reference to what? So the x-axis, and find the reference to what now? The y-axis. If, for example, this place is, let me say 2, and this place is 1.5, for example. If I say I should find what now? That point, I'm going to use what? Usually we write the points by coordinates. X coordinates and what now? Y coordinate. The x coordinate comes first. That's the value on the x-axis. This is the x coordinate. So I have 2, and then I'll have what now? 1.5 forward for the y coordinate. So somebody that understands how to find the position on the graph can easily just come and know that this is the point I'm talking about. This is the point A that I'm talking about. Using what now? So what is position in other words? Let's see this. The position of an object in relation to some reference point gives what now? The location of that object. The position of an object in relation to some reference point gives the location of that object. That is position. So I've explained that. Let me use this other part of the board. If, for example, I give you a point, let me say, I gave you this point here, and I call it x, and I gave you another point here. Let me use this point. I give you another point here. Sorry. Okay, this point, and I call it y. And I say you should locate what? Locate the position. How do you find it? So I'm going to come, and remember I said we could just draw the lines. I'll try and locate in this direction to 3, in this direction to what? To -2. This one, I drag it to the x-axis, I get what now? 4. To the what? To the y-axis, I get what now? I get -3. So if I call this, if I ask you to give me the location of the point x, what is it going to be? It's going to be what's the x value? The x value is -2. The y value is what now? It's 3. So that is what now? The coordinates. I can locate that point. This one is going to be what now? X value is 4, and then the y value is negative what now? 3. That is how we get position. So the position actually gives you the location of the what? Of the object on a plane. So if I'm not doing distance, which is going to be the next now, I can now say what? What exactly is going to be the distance from this point to, sorry about that, the distance from this point to this point. How far will I travel to move from x to what now? To y. That's what distance is about. So if I ask you that, that will take me to